Hey guys, I hope that I can't make that dig and stop. I tried. So anyway, hope everybody's doing well. I put lesson 7.1 up. Everything's on Blackboard. You'll see there are new test dates and quiz dates and things like that on Hawks. Quiz 5 is 7.1 and it is due sometime. You'll have to look on Hawks and see. Okay, so the next lesson is 7.4. So here we go. Email me if you have questions, and hope everybody's doing well. So I'm going to go let you see my paper. Here we go. Okay, the next lesson is 7.4, and it's called Improper Integrals. Wait a minute. I know what I'm doing here because I was told, and I like positive reinforcement, that maybe it was too dark. I mean, it wasn't dark enough. So this is called Improper Integrals. And you can't see that because it's too light. Let's see. There. Improper integrals, 7.4. Okay, so what is an improper integral? So if I have the integral, I'm going to just show you what it is. I'm going to show you what it is, and then we're going to work some problems. But I can't just start working problems until I tell you what it is, okay? So if I have an integral from some number to infinity, that's what makes it improper, the infinity on top, of f of x dx, okay? All right, so let's just say an example. Let's just show you a picture, and I'll go back to that. If I had the integral from 5 to infinity of 3 over x squared. Now we know from 6.4 that if this lies above the x-axis from 5 to infinity, and it does, you won't have to know how to graph that. So if we look at it from 5 to infinity, it lies above the x-axis. So if we integrate it, this should give us our area between the curve and the x-axis, okay? All right, so what we do in calculus is we take a problem that we already know how to do and do it and apply that knowledge to this problem that we don't know how to do. So what we're used to integrating from A to B. So we're going to just cut this off right here at some number B, okay? So let's go back. I'll write down the formula, and let's look at it, okay? So when I have an improper integral, I'm going to rewrite this as the integral from A to B of f of x dx, okay? And I'm going to use my 6.1 rules to find my antiderivative, capital F of x. So f of x is the antiderivative from A to B of f of x dx. And so what we do is that we evaluate it from A to B, just like in 6.3b, and we get what? F of B minus f of A. So that's nothing new, okay? The only thing that we've done is we've changed this infinity to a B, because back to my example, that's what I'm used to having a number up here. So I'm going to change this infinity to B. So let me go through and show you by example what I've done so far there. So I wonder if this would do better if I didn't have so much light right there. Is that better? Okay. All right. So here we go. If I take this integral from 5 to B, 3x to the negative 2 dx. Okay, I'm going to use my 6.1 rules to integrate it. And so I add 1 to the exponent, and I get 3x to the negative 1, and I'm going to divide by negative 1. Okay, so I can call my antiderivative what? Negative 3x to the negative 1. Nothing new. Okay, so now I'm going to evaluate this from 5 to b. And we're used to having a number like 8 or 10 or something up there, but we're going to just do the fundamental theorem of calculus, f of b minus f of 5. Okay. And what section did we learn? That was 6.3b, right? We learned to plug in our limits. Okay, so we made our parentheses and we plugged in the b. And then we're going to plug in the 5. Okay, so almost exactly what we've done so far. F of b minus f of a. Okay, but the deal is that we don't want to know, we don't want to evaluate it from a to b. We want to evaluate it from a to infinity. All right, so this is where some new old stuff is going to come in. Okay, so we're going to take the limit as b approaches infinity of f of b minus f of a. Okay, because I changed my infinity to b. So instead of finding the integral from a to b, I want to take the limit as b approaches infinity to figure out what that limit is. But that was a long time ago, right, when we did our infinite limits. So let's just go do an a Business Cal 1 review. Okay, so 267, infinite limit review. Okay, and we had 3 cases in 267, but we're only going to be dealing with, we had 3 cases in 267. We always look for the highest power, okay? So it's always going to be a b. So remember, when we take limits, we can just make a chart and see, look at the behavior, okay? So let's do that. If I take the limit as b approaches infinity of, let's say, 3b, okay? All right, so what that means is I am going to make a chart, and as b approaches infinity means as b gets bigger and bigger. As b gets bigger, what does 3b do? So let's take some numbers. As b approaches infinity, let's take big numbers. If b is 100 and we plug it in, we get 300. If b is 1,000 and we plug it in, we get 3,000. If b is 10,000 and we plug it in, b is 30,000. Okay, so can you tell me, as b gets bigger and bigger, as b approaches infinity, what does 3b do? It gets bigger, right? And how do you say gets bigger in math? It goes to infinity, okay? All right, so this limit would be infinity, okay? So in general, we can say if the highest power of b or if b, because we're just going to have one b, if b is in the numerator, then the limit as b approaches infinity of my f of b is going to be infinity, okay? So if we have the limit as b approaches infinity, and we had like e to the 2b plus 5, okay? How would we find that limit? Whoops, maybe you should see it. Limit as b approaches infinity. So we just look for b, and b is only going to be in this first term. And so that's over 1, right? So b is in the numerator. If b is in the numerator, then this limit right here is always going to be infinity, because if we plug in 100, we get e to the 200, e to the 2000, e to the, it just gets bigger and bigger and bigger. And infinity plus 5 is just going to be infinity. Infinity plus or minus any number is always just going to be infinity. Okay, so that is the case if b is in the numerator. Okay, now let's do b in the denominator, because b is going to be either in the numerator or the denominator. So if I have the limit as b approaches infinity of 3 over b. Okay, so we always, whenever we first learned about limits, we made a chart. Okay, and if b approaches infinity, that means as b gets bigger, bigger and bigger and bigger, what does 3 over b do? So let's plug in some things and find out. If b is 100, we get 3 over 100. If b is 1,000, we get 3 over 1,000. If b is 10,000, we get 3 over 10,000. Okay, so let's see. So if 3b got bigger and bigger and bigger, okay, you might say this gets smaller and smaller and smaller, but smaller would mean negative infinity. So what are these values getting closer and closer to? They're not going to negative infinity, they're getting closer and closer to 0, okay? So we can say the limit as b approaches infinity of f of b is always going to be 0 when b is in the denominator. Okay, so an example of that limit would be if I had the limit as b approaches infinity and I have 5 over 3b squared plus 17. Okay, so the first term is the one I'm always going to have b in, and it's either going to be infinity or it's going to be 0. So if b is in the denominator gets bigger and bigger and bigger. This 5 over b squared is going to go to 0, and 0 plus 17 is 17. Okay, so those are the two types of limits that we're going to have. Okay, so when we take the limit and b is in the numerator, okay, we're going to get infinity plus a number or infinity minus a number, which is always infinity. Okay, and if b is in the denominator, when we take the limit, that's going to be 0 plus a number. All right, so that's our review. Now let's go over here. I got all kinds of paper. My review. And so let's look at my example first. Okay. All right. So this is, we have to take the limit. So the limit as b approaches infinity this is negative 3 times b to the negative 1 minus negative 3 times 5 to the negative 1. Did everybody remember that? We plugged b into my antiderivative and got that. And we plugged 5 into my antiderivative and got that. Okay, so this first term always has b in it, but is b in the numerator or the denominator? I used to teach it where I would simplify the antiderivative. So f of x is really what? Negative 3 over x. So x is in the denominator, so b would be in the denominator, but we haven't been simplifying it, so let's don't start now. So what we're going to say is that if the exponent on b is negative, we have two cases. Then the limit as b approaches infinity of b to a negative exponent plus a number is always going to be 0 plus the number, which is just a number. Okay? And if the exponent on b is positive, then the limit as b approaches infinity of b to a positive exponent, and it's minus a number, will be infinity minus a number, which is infinity. Okay, so on one of these we're going to get 0, and on one of these we're going to get a number. Okay, all right, so let's go back to my example. Okay, so when I take the limit as b approaches infinity, this b has a negative exponent, so it's really in the denominator. So b is in the denominator, or if the exponent on b is negative, that limit is going to be 0. Minus a negative is plus 3 times 5 to the negative 1. So that is 3 times 5 to the negative 1, which the computer will take, or you can put it in your calculator and call it 3/5. And that's your answer. Okay. And so when we go and talk about this area, it doesn't really make sense that we would have an infinite area. But what's happening is my graph is getting closer and closer and closer and closer to the x-axis. And so we say it converges to 3/5. Okay, so whenever we get a number, we're going to say it converges. Okay. If we were to get our answer to be infinity, that means that our graph gets bigger and bigger and bigger and bigger, and it blows up. So we're going to say that diverges. Okay, so here's that. Okay. Okay, so let's do some problems. I think you like to do that better. And we'll look at our steps, okay? We're going to take this limit. So here's example 1. Not the limit. We're going to take this example. The integral from 3 to infinity of 4 over x to the 4th dx. Okay, so the only thing strange about this is this infinity right here. Okay, so what we're going to do is take this problem and turn it into something that we already know how to do. We're going to rewrite this as the integral from 3 to b. We're going to cut it off at b, 4x to the negative 4 dx, because when we find the antiderivative, we're going to use our 6.1 rules, and we're just going to add 1 and divide, or use e to the kx. Okay, so here we bring our constant over, add 1 to the exponent, and divide by negative 3. Okay, so here is our antiderivative. And we have to evaluate it from 3 to b. Okay, so we're going to say f of b minus f of 3. So let's put this here. F of x is 4x to the negative 3 over negative 3. And we're going to evaluate it from 3 to b. This is just a dot. It's not a negative. Okay, so f of b minus f of 3. So I make my parentheses like I always do. I take b and I plug it in for x. So I have 4 times b to the negative 3 over negative 3. And I take my 3 and I plug it in for x. And I have 4 times 3 to the negative 3 over negative 3. Lots of 3's. Okay. All right. So I don't care anything about b. Okay. I want to know what happens at infinity. So that's the new part. So that means I take the limit as b approaches infinity. This first term will always have b in it, and that is 4 times b to the negative 3 over negative 3 minus the negative okay, because I just turned those two minuses into a plus. Okay, so let's take the limit. Remember, if the exponent on b is negative, it belongs in the bottom. Let's look at our paper. Remember, we said when we do the infinite limits, if b is in the bottom, then it's always, we can just generalize that this is going to go to 0, okay? And so we can say if the b is in the denominator, or if the exponent on b is negative, same thing. If the exponent on b is negative, it means b is in the bottom, and we're always going to get 0 plus a number. Okay, all right. So when we take the limit, b has a negative exponent, so it's in the bottom, so it's 0 plus 4 times 3 to the negative 3 over 3, which is 4 times 3 to the negative 3 over 3, which you can leave like that. I don't think Hawks lets you put a parenthesis in the fraction bar, or you can put it in your calculator and write it as what's 3 cubed, just sometimes it's 4 over 27, okay? And since we get a number, 4 over 27, since we get a number, whenever the exponent on b is negative, we get 0 plus a number, and so we say it converges. So it converges to 4 over 27. And it'll always be a positive number because remember the picture we drew earlier, we were talking about area. Okay? And that's it. We're going to do the same steps every single time. We're either going to end up with 0 plus a number when we take this limit, and our number is our answer, and we say it's convergent, or we're going to get infinity minus a number and say it's divergent. Let's look at another example. Let's do the integral from 4 to infinity of 7 over the square root of x dx. Okay, so remember, I'm going to rewrite this and get rid of that infinity. So that's the integral from 4 to b of 7x to the negative 1/2 dx. Don't forget, we have to integrate it. We have to use our 6.1 rules. So that is 7x. When I add 1 to negative 1/2, what do I get? Positive 1/2, and I divide by positive 1/2, or multiply by 2. So my antiderivative is 14x to the 1/2. Okay. And that's from 6.1. And now I evaluate it from 4 to b. And this is 6.3b. So we do f of b minus f of 4. Ooh, that scared me. So remember, you take your b and you plug it in for x, make my parentheses. So 14 times b to the 1/2 minus 14 times 4 to the 1/2. Okay. So we plug in the top and plug in the bottom. And then we have to figure out what this is right here. So we always take the limit as b approaches infinity of 14 times b to the 1/2 minus 14 times 4 to the 1/2. Okay, so when I take the limit as b approaches infinity, remember that's over 1. So as b gets bigger and bigger and bigger, b to the 1/2 gets bigger and bigger and bigger. Remember, this is the new stuff. This is where everybody will go, what are you talking about? So at this point right here, you look at the exponent on b, okay? If the exponent on b is negative, it belongs in the bottom, so it's going to be 0 plus a number and it converges. If the exponent on b is positive, then it stays in the top and b gets bigger and bigger and bigger. So it's always infinity, and it's infinity minus a number. So here, if b gets bigger and bigger and bigger, that's going to be infinity, and we don't even have to figure out what the number is, because infinity minus any number is always infinity. And we say it diverges, or it's divergent. Okay, so the area, it blows up. If we were looking at the graph, it doesn't get closer and closer to the x-axis. It just keeps getting bigger and bigger and bigger. It blows up. And so our answers are always going to be 0 plus a number. The number is convergent. Infinity minus a number. Infinity is divergent or diverges. So on Hawks, they'll ask you first if it's convergent or divergent. If it's convergent, you put the number in there. And if it's divergent, you just click on divergent and you're done. You don't put anything in the box, and they won't let you put anything in the box. Okay, let's look at this. 5 to infinity, 3 over 2x to the 4th. And be careful here. It's not so much the calculus, it's the rewriting of this. Well, first off, yeah, it is the rewriting of this. So we're going to change that infinity to b, right? And then my constant is 3 over 2. But remember, you only move the x up. Okay, don't move the 2 up. That's how people really mess up. That's x to the negative 4 dx. So be really careful right at the beginning. Okay, so these are always 6.1, add 1 divide, or e to the kx. So that's 3/2 x. When I add 1 to my exponent, my new exponent is -3, and I divide by -3. Okay, you can reduce or not reduce. It doesn't matter. Oops, I can't make that go away. So I have 3x to the -3 over -6. Let's say we don't reduce. And I have to evaluate it from 5 to b. And so that's f of b minus f of 5, meaning I'm taking my top and I'm plugging it in for x. So I have 3 times b to the -3 over -6. And then I'm taking my 5 and plugging it in for x. 3 times 5 to the -3 over negative 6. Okay. So I got to get rid of that b. So that's where I have to remember. It's where my infinity comes in. This is the limit as b approaches infinity. Let's try to clean this up a little bit. 3 times b to the negative 3 over negative 6 minus a negative, okay, plus 3 times 5 to the negative 3 over 6. Okay, so we have to decide right here, is this first term going to be 0 or is it going to be infinity? Okay, so remember, we always look for the exponent on b. If the exponent on b is negative, that means it's really in the bottom, and that's always going to be 0. And it's 0 plus a number because we're talking about area, so it's not going to ever be negative. Or b has a positive exponent and it gets bigger, so it's infinity minus a number, and it's infinity and it diverges. Okay, so what does this do? The exponent on b is negative, so that's 0 plus 3 times 5 to the negative 3 over 6, which is, you're not going to believe this, but I don't have my calculator. Okay, so I don't have my calculator. And that's 3 times 5 to the negative 3 over 6. And the calculator will tell you what the fraction is. You have to leave it as a fraction, no decimal. But look, I don't have my calculator. And when I go make my fraction bar, it won't let me type it in. So on the computer, I have to say that's 3 over 6 times 5 to the negative 3. And because that's a number, it's convergent. And so 125, let me figure out what that number is. Oh, I've got my phone. Hello. All right, so if you don't want to type it in like that, it's 125 times 6 is 750. So it's 3 over 750, and it's convergent. Or you can put it in like this. It doesn't matter. They won't let you put the parenthesis in the fraction bar. So if you're going to do it like this, just do the 3 over 6 and scooch over and do the 5 to the negative 3. Or put it in your calculator and do the double arrow, and it'll give you 3 over 750. But remember, it won't take a decimal, no decimal. So you have to leave it as a fraction. So that's not too bad. That's all there is in this section. I'm going to work one more example with an E. And I'm just going to let you try. And then if you have questions, you can ask me. Okay? Okay. All right. So the limit from 3 to infinity of, let's say, 10e to the negative 0.2x dx. Okay. All right. So the only rewriting I have to do is this infinity, right? I don't have any x's to move up. So we'll rewrite that as the integral from 3 to b of 10e to the negative 0.2x dx. And so when I integrate e to the kx, a constant times e to the kx, it's my constant times e to the negative 0.2x, and I divide by negative 0.2. Okay, so my antiderivative, I'm going to see if that makes a nicer number. Sometimes, most of the time it does. So 10 divided by 0.2 is going to be negative 50 e to the negative 0.2x. Okay, so I have to evaluate it from 3 to b. All right, so f of b minus f of 3. I plug b in for x. Negative 0.2b It's a little sloppy. You know I'm sloppy. Minus negative 50 e to the negative 0.2 times 3 is negative 0.6. Okay. You plug it in your calculator. Negative 0.6. So I got to get rid of the b. So now I take the limit as b approaches infinity. So b is negative. So the exponent is negative, and that means what? It's going to go on the bottom. Are y'all good with that? So b is negative. It's 0 plus a number, and it's convergent. Okay? And if b has a positive exponent, it's infinity minus a number, and it diverges. So this is negative. It goes on the bottom, so that's going to be 0 minus a negative plus 50e to the negative 0.6, which is 50e to the negative 0.6. They won't take a decimal, and so you'll have to put it in like that, and it's convergent since we got a number. Now, Hawks will put it in as 50 over e to the 0.6, but you don't have to simplify. That's just how Hawks. This is fine. These are the same. And that's it. Email me with questions. I've got all the Hawks stuff assigned, and the dates are new, and so your quiz 5 just has 7.1, which we've already covered. And then quiz 6 has 7.4 and 7.5. And so tomorrow I'll put a 7.5 video up. And, you know, I know y'all have a lot of stuff online, you know, and I'm just trying to get this stuff early. And we have cut out a ton of stuff just so you get the basics, and I'm here to help you. I'm still not sure about a Zoom office hour because I think it would just be easier to do it by email, or, I mean, I'm open to do whatever, but you sitting there, me sitting here with nothing to write on. I mean, I won't be in quarantine forever, but for now, what is it, Sunday? So Monday, Tuesday, so 10 more days, you know, I'm stuck here at home. I don't have a chalkboard. I have a little whiteboard. So if you want me to work a problem or something like that, and I can do anything. I'm open to suggestions. So I just want to, I'm sorry this has happened. It's hard on you to change everything in the middle. So I want to help you as much as I can. And so you just got to reach out. Don't wait till the last minute. Just reach out. If you're, you know, just reach out. All right, guys, you got this. We can do it. I mean, you'll be telling when it's going to be a story one day about the big, you know, coronavirus. So please stay healthy, and, you know, this is not a vacation. We're trying not to spread the disease. So get to work. Let me know if you have questions. All right, you got this. I'll see you soon. See ya. Bye.